we're starting. All right, so for year 12s, and maybe year 11s as well, year 11s, I won't be testing too much algebra per se, but you still need to know how to do simultaneous equations. Alright, so year 12s, you do need to know how to do simultaneous equations. Means algebra, and it is probably the most intense, but it's only about 1 or 2 marks in the entire exam. So if you know how to do it, great. If you don't, then they generally expect you to know how to do it through graphs. So that's the back of the page. I'll show you what it looks like. For year 11, same thing. I'm going to expect that on the exam, you guys will know how to do it graphically. Obviously, if you know how to do it mathematically, it'll be much quicker, but it does require that you know your algebra from 4.2, 4.3, and 4.4. Yeah? So here's some examples. Let's fill out a couple of notes. We use simultaneous equations to solve the... What is the simultaneous equations for? It's the intersection of two straight lines. That's the whole point. So learning that algebra allows you to find when do they both cross each other. There are only 2 methods that you would have learnt previously. It's substitution method, which arguably is the easiest way to understand it. Elimination method, for those who are strong with their algebra, is the fastest way to do it. In this exercise, we will only focus on substitution because it's the easiest way to explain it. Okay? So I'm going to show substitution. If you can do substitution, fantastic. If you can't, it's okay. We're going to have to do it like guessing-wise. Here we go. Boys in the back, can you please start copying notes instead of looking at your laptops? Means have a pen ready. And copy notes. All right, here we go. Example 1. This is the expectation. Y1 is x plus 3 and y2 is 2x plus 5. Usually they give you the graph. Okay, so you're not fully expected to sketch this on your own anymore. You can do it. There is part of the exercise. They do get you to sketch it from scratch. We don't expect that at foundation exam, but you do need to be able to look at a graph and tell me where is the point of intersection. Okay. Now looking at the graph, the point of intersection clearly occurs right at this particular point. What's the coordinates of this particular point? Can I please have, let's go with Billy. Point of intersection, what would that coordinate be?
That'd be -2.
-2 on the x-axis, and what's the y value? -2 on the x, because it goes -1, -2. And then you're right, it is +1. +1 on the y. Yes. So on the y, it's +1. On the x is -2. So the coordinates would be -2, 1. Now you can tell that from looking at the graph. Yeah.
You have to do, when you write -2 and 1, you have to do 1 for the other, like x first.
Yeah, always. X always comes first, y comes second. So yes, it has to be -2, 1, not 1, -2. Now, that's the graphical sense. So some of your questions will be this nice, and the exams will usually give you this kind of graph and then ask you to predict what happens in the future just by looking at the graph. But there is parts of the exam where you do have to know how to do this manually, so algebraically. So sometimes they don't give you the grid and you can't see what the actual value is, so you actually have to calculate it. So what's the thing about the point of intersection? What's the technique? The technique is that the y value is the blue line and the red line. They clearly have very different points. But the only time they have the same point is literally at the intersection. So what we can say is that at the point of intersection, both the x's for the blue line and the red line must be the same, and both the y values for the red and blue line must be the same. What I'm essentially saying is that the blue line must have -2, 1 somewhere, and the red line must also have -2, 1 somewhere. The problem is that we didn't know it was -2, 1 unless I had a graph. So mathematically, this is what we say. We say, well, since I don't know it was negative 2, 1, imagine I didn't know that. I call this x and I call that y. So they say both x and y must be the same because these two x coordinates have to be the same and these two y coordinates have to be the same for you to be a point of intersection. So that's why if x's and y's are the same, I can say y1, whatever that equation is, must equal to y2 only at the point of intersection. That's the only time where these two coordinates are the same. So what is y1? Well, conveniently, we had x plus 3. What was y2? Well, y2 is equal to 2x plus 5. This is a hypothetical situation, an equation, that if you can solve for x, that tells you exactly where it should match. That's what we're doing. We're doing hypothetical here. So that's why I was saying that in foundation, we don't generally do hypothetical, but interestingly enough, in your study design, it is required. It is part for you to do this. I just don't see the point of it if you're not doing the hypothetical component lots. But if you want to earn that 1 or 2 marks for the end of year exam, then yeah, this is a skill to learn. So here we go. Going back to what you've done, if you've practiced exercise 4.2 and 4.3 from the year 12 textbook, this is now back to something that you're familiar with. We've got 2 x's on either side, an x and a 2x. In the last session, I did say or give you a tip on which one to get rid of. Does anyone remember what I said? The smaller one. Yeah, so out of the two, this one is 1 and that one's 2. Get rid of the smaller one. So how do you get rid of them? That's a positive x. What's the opposite of positive x? Negative x. So you minus x on the left. Then whatever you do to the left, you must do to the right. X take away x, we know is going to cancel out. That's 0 because they're opposite of one another. So this cancels out. On the left side, I still have 3. 3 still left over. On the right-hand side, 2x take away 1x. How many x's do I have left? 1x. So we just write 1x plus 5. And then from here, this is what you were doing with Sam Dobb the whole time. Sam Dobb that I was trying to teach you. Get rid of subtraction addition first. There is no multiplication division. I only got that plus 5. That's the plus 5 I want to get rid of. And opposite of plus 5 we know is minus 5. Whatever you do to one side, you do to the other side. Plus 5 take away 5 cancels out. I now have x left over. And 3 take away 5 is negative 2. See, so even if I didn't have the graph before, using the theory, which is that when you have a point of intersection, both the x and the y coordinates are the same.
Yeah, and then y equals x plus 3. You do, since x is minus 2, you just add 3 to that, which is 1.
That's it. And so that's how you get both the x and y coordinates. So since now you've been able to work out what x is, and the y equation was you either had y is equal to x plus 3, or you had y is equal to 2x plus 5. Remember, the x's are going to be the same, so it doesn't matter which one you put in. You can substitute x equals to negative 2 for this equation, or you can sub x equals to negative 2 for this one, and both the answers should be the same. Because theoretically, that's what we were saying. We're saying both the y's should be the same. So here we go. Let's see if it actually equals. If I subbed into y1, x, which is negative 2, it becomes negative 2 plus 3. What's negative 2 plus 3? 1. That's 1. Let's try this one. Let's see if it equals to the same thing. So y1 will equal to 1 if I sub negative 2 in. Let's try the second equation. Second equation was y2. If I subbed in 2 times negative 2 plus 5, let's see if that works out the same. 2 times negative 2 is negative 4. Negative 4 plus 5 happens to give you 1 as well. This is why when you first learnt it back in the past, it didn't matter where you sub it in. Because the whole theory was that x is always going to be the same. And if x was the same, y's have to be the same. You worked out when x will be the same. This theoretically was probably one of the hardest for students to understand early on. Okay, and that's why I'm saying I find it surprising that in foundation maths that this is part of your study design, because theoretically it's quite involved. There's a lot that you have to think about hypothetically to make sense out of that. So if you get it, fantastic. If you don't, I really don't think there's much importance to it. You can probably do an extrapolation, guess roughly where it is, and predict. That's pretty much what they'll do in the exam. But if you've got that little extra skill there to be able to learn how to do simultaneous equations, that adds on that 1 or 2 marks.
Why is y2 1 then? If y2 is minus 2, then why is it 1?
No, so x is -2. So this is the equation for y2. So when x is equal to -2, saying when it's -2, the blue line, which is y2, what would the y value be?
Oh, yeah.
And so I subbed it in, and I subbed at -2, tell me what the y value is. It turns out it was exactly the same, which we predicted would be the same. Yeah.
My bad.
Yeah. It is, like I said, it is quite a involved theoretical concept. If you get it, good for you. If you don't, doesn't matter. Yeah? All right, team. So that's the main part of 4.6. Flip over the page. Flip over the page. Make sure to copy this down, team, because I know it is tricky. But the next page, I do want you to copy it down because it gives you a technique. Even if you don't know how to do simultaneous, you know what you might want to do first. Okay, so make sure to copy. All right, flip over the page. Here we go. 3, 2, 1. Last example for today. So this is a typical exam question that you might then have to use simultaneous equations. So here, but you don't have to. You can kind of guess it, yeah? Here's an example. Say I hired a car for a fee of $120 plus $30 for every day. Okay, so for every day that my hires the car, that's $30 per day. But before that, you always have to pay $120 first. So $120, and then for every day you hire it, it's an extra $30, yeah, per day. Versus Casey's rate, it was $180, so a steeper upfront fee. So steeper upfront, but slightly less per day. The question is, which one is better value? Well, usually one will get more expensive than the other. Okay, so now we don't know which one. Do you want to fork up a lot more money at the start and pay a bit less per day? Or do you prefer to pay less upfront and then pay a bit more per day? Which one works out better? Depends on the number of days you actually do it for. So when the question asks, how long will Mai and Casey have to rent the cars to have the same final cost? That is a simultaneous equation. See, that is when you actually do a prediction, which one is better and for how many days do you have to hire the car so that the cost actually is the same. Now, for the general students, as in like anyone, not just general maths, I meant generally, this is probably the approach you would do it logically. There's an approach to it. This is the actual maths if you were to learn it. Okay, so I'm going to show you the logic. Here's the intuitive way. You know that for Mai's rate, it was $120 plus $30 per day. All right? So logically, if Mai only borrowed it for 0 days, she would have to pay $120 plus 0 times 30. Shh, boys. Thanks. So the first cost, we can tell that for Mai's rate, it should have been $120 to start off with. Same thing with Casey. Casey had to put an upfront of $180. But if you think about the next bits, you guys can all figure this one out logically. If it's $30 for every day, that's $120 with an extra 30 days, or $30 per day. So that means $120 plus 30, Mai would have to pay $150. What about Casey? Casey pays $180 to start off with, but then it's $26 per day. So for only 1 day of hire, $180 plus 26, they pay $206. So after 1 day of hire, which one is clearly more expensive? Casey's rate. Casey's rate's not as good. It looks like My's rental is pretty good. But My's rental is a lot more per day. So the question is, how long before Casey's rate pays off? Because Casey's is slightly cheaper. So how long before that happens? You can keep guessing the numbers, and I chose the number 10. What if they borrowed it for 10 days? So if we do it for 10 days, $120 up front for My, plus $30 per day. Now, if they did $30 per day and they borrowed it for 10 days, how much would they have to pay? If it's $30 per day and they hired it for 10 days, $300. So you know it's 30 times 10, 120 plus 300 gives you now 500, oh, sorry, 420.
It wouldn't be 300 because sorry, I thought you were doing 150. That's what I did. I did 150 because we've already got that, and then just times it by 9.
Oh yeah, that works too. That's good. Oh, that's true. That would work too. That's a good idea. Yeah. So I got 420 for My, but if you did it for Casey, if Casey had to pay 180 upfront, but then 10 days of hire would mean that at $26 per day, it's 26 times 10. So in total, 180 plus 260, this now gives us, how much is that? That's what? That's $440. Well, we can see now the gap is a lot closer. Casey is still more expensive after 10 days of hire. It's probably still better to go with My because it's $20 less. But we can already see that Casey's rental is catching up. So very likely if I went to 20 days, let's see. So 20 times 30. So 20 days for $30 per day. That gives you $600. And you're right. That will cost $720 for My versus Casey. Casey pays a steep upfront fee of $180, but only $26 or $4 less per day times 20. Well, you see now, 26 times 20 gives you, what's double of 26? That's 520. 520, so there we go. Adding them both together, what does that give you? $700. Now, it turns out that instead of My's price being cheaper, it's clearly now Casey's price is a lot cheaper. So if you had to answer the question, how many days would it take for Casey's rent to be cheaper? We can already kind of guess. At 10, it was 440 versus 420. It's probably somewhere around 11, 12, or 13. And you can kind of guess your answer and then get your answer from that, if this was the exam. What's the problem? This technique takes a long time to do. As you can see, the way I've just done it, there's a lot of trial and error, but it's very intuitive. You can kind of guess it and work. If you had a lot of time in the exam, you could eventually figure it out that it's somewhere between 10 days and 20 days. Means it was,
That's money.
Sorry, this is money. I should cross that off. So it should be, if we keep guessing, it's somewhere between 10 and 20 days where they will have the same pricing. Okay? That skill that I just showed you, that is probably the most useful, logic, intuitive. That's what the foundation generally course is meant to be about. It's meant to be intuition, it's meant to be logic, and you figure it out. So that approach, yes, whilst it works, it takes a very long time to do. Whereas if you actually learn the substitution method from 4.6, you would have got the answer directly and exactly a lot quicker. But you got to learn the skill. So here, same idea. Cost for My was $120 up front plus 30 times the number of days. Versus Casey, $180 up front, $26 per day. If we now solve this problem, This is very similar to what we were doing before. We want to check when will My's cost equal to the cost of Casey. My's cost is 120 plus 30D. And this is why it's similar to what we just did before. 120 plus 30D. This is 180 up front plus 26 per day. And then from here, this is what you do, what I was trying to teach you. How do you solve for the unknown? What's the tip again? If you got two unknowns on both sides, which one do you get rid of? The smaller one. So the 26D, not the 30D. This is positive 26D, so the opposite of positive, minus. So minus 26D on the right, minus 26D on the left. These will cancel out. You end up with 120 plus 30 take away 26 is 4. And once you're up to this, this is what I've been asking you to practice. 4.3 was SAMDUB. So if you haven't practiced SAMDUB, that's one of the reasons why I said with it, it allows you to solve this bit. So from here, SAMDUB, addition, subtraction first. Clearly you got a plus 120. Opposite of positive 120? Negative 120. So minus 120 on the left, minus 120 on the right. These two cancel out. 4 times D, or 4 times the number of days, is equal to 180 take away 120. Gives you 60. So that means if you got 4 groups of D to make 60, and you only want to know what D actually equals to, divide, because that's the opposite of times. 4 divided by 4 cancels out. 60 divided by 4, which gives you, is it 15? Yes, you're right. So what does that mean? It takes 15 days for it to equal. So that means if I want to use Casey's hiring company, I just got to check that I'm going to hire for more than 15 days. If I hire for more than 15 days, it's a lot cheaper to go with Casey. If I hire for less than 15 days, I'll go with My. But that skill that I just said there, this is 4.6. This is intuition. Okay, not easy. I'm not saying it's easy. I do know this is a very pushing concept. And like I said, chapter 4 is a small component. If you don't get it, it's okay. We're mainly meant to be focusing on finance. Okay, so financial mathematics. But if you can build on that skill, that's the key thing. So I'm going to pause the video here. And that's for you to copy my notes.